A customer service AI says an urgent part is in stock. It's not. The company loses thousands of dollars. This is what happens when AI guesses instead of checking. Today we fix that with ReAct prompting, the loop that gives your model real-world actions so it never has to guess again. Welcome to Part 5 of our Prompt Engineering Masterclass. I'm your host, and by the end of this video, you'll be able to build an agent that actually looks things up before it answers. Before we jump into ReAct, think of the last time an AI confidently gave you a wrong answer because it couldn't look anything up. That's the problem we solve today. We've built the foundation step by step. 0 shot, 1 shot, few shot, then chain of thought reasoning, where the model walks through intermediate steps before answering. Now we add action to the reasoning. Imagine asking, what's the square root of the current population of Tokyo? Without this, the model guesses the population from memory and gets it wrong. With ReAct, it searches for the population first, gets a verified number, then calculates the root. That's the difference. This is how AI agents actually think. It's called ReAct. By the end of this video, you'll have 3 concrete skills. First, you'll be able to explain the ReAct loop: thought, action, observation, from memory. And you'll understand why it adds external actions to chain of thought reasoning, grounding each step in real-world data. Second, you'll have written a real agent that calls tools, not just a theory. And third, you'll understand why this loop is a core pattern used in modern agent systems. Let's lock in the lesson from that opening story before we move forward. ReAct stands for reasoning plus acting. It's a prompting technique where the model alternates between 2 things: writing down its reasoning, called a thought, and calling an external tool, an action. It then reads the tool's result, the observation, before deciding the next step. Every fact the model uses gets grounded by a real-world check, not a memorized approximation. That loop, thought, action, observation, repeats until the model has enough verified information to give a final answer. This is the entire cognitive architecture in one slide. The agent reasons, thought, decides to call a tool, action, and then reads the result, observation. That observation feeds the next thought, and the cycle continues. The loop only breaks when the model emits a final answer instead of another action. Here's a real trace. The user asks, which city is larger? The model thinks, I need populations. It searches for Paris, gets back 2.1 million. Then it reasons, now I need Tokyo. Searches again, finds 13.96 million. Finally, it concludes, Tokyo is larger. Every single number in this chain came from a live search, not from the model's flaky memory. That's the power of interleaving thoughts with real observations. The cycle of think, act, observe is the heartbeat of many modern AI agents. Burn it into memory. But here's a part that saves hours of debugging. When things go wrong, follow the observations, not the thoughts. If the observation is wrong, the next thought is built on garbage. That's why logging every observation is step 1 in production. The first piece of the loop is thought. Think of it as the model's inner monologue. It writes a plain English sentence like, I need the current stock price of AAPL. I'll search for it. That sentence isn't hidden logic. It's visible reasoning that tells you exactly what the model plans to do next. Honest, auditable, and the foundation of the whole ReAct pattern. Quick checkpoint. You've seen the ReAct loop, including the thought step. Based on that, answer this. Observation is the third and most important piece, the raw output from the tool, dropped right back into the prompt. Now the next thought isn't built on a fuzzy memory of a stock price. It's anchored to a real number. This is the mechanism that slashes hallucinations in multi-step tasks. We've covered thought, action, and observation one by one. Let's lock it in. What are the three components of a ReAct step? The agent itself decides when to stop. Once it has gathered enough verified information, it outputs final answer instead of another action. The host runtime detects that phrase, breaks the loop, and returns the answer to you. Many production systems also add a safety limit, but the core loop relies on the agent's own judgment. Here's a real system prompt that turns a generic language model into a ReAct agent. It defines the agent's role, lists the tools it can use, and, crucially, mandates the thought-action-observation rhythm. Notice the phrase, decompose complex goals into manageable subtasks. That's the blueprint the agent follows on every single step. Without this system prompt, the model defaults to a single-shot answer from memory. No verification, no tools, no safety net. The prompt template is the rulebook that forces the thought-action-observation loop. Change this paragraph and you change the agent's entire behavior. These are the 4 tools most ReAct agents carry. Search for live information. Calculator for precise math. A Python interpreter for one-off logic. And generic API calls for anything else. But here's the rule most beginners miss. An agent can only use tools you explicitly hand it. Limit the toolbox and you limit the risk. ReAct is much more than a prompting trick. It introduced a simple but powerful idea. Let the model reason about what it needs. Use a tool to gather information, observe the result, then continue solving the problem. Today, many AI agent frameworks build on this same concept. Whether an agent is searching documentation, querying a database, executing Python code, or calling an external API, it follows the same basic cycle. Decide, act, observe, and continue. Understanding this pattern helps you understand how modern AI agents work under the hood, even when the framework hides the implementation details. Quick recall. Why does a ReAct agent need a system prompt that describes its available tools? If you said because the model can't call a tool it doesn't know exists, you're exactly right. Without that tool list, the agent guesses answers from memory instead of using live data. Watch the agent in action. We ask, what is the square root of the current population of Tokyo? The trace illustrates it searching for the population, getting the figure, switching to the calculator tool, and then writing final answer after computing the result. Every step is grounded. No hallucination, just a transparent chain of verified facts. Zero-shot ReAct runs on a system prompt and a question. The model has to guess the action format from written instructions. One misplaced colon and your agent spirals. Few-shot ReAct is the same idea you already learned in Part 2. You prepend 1 or 2 complete traces showing thought, action, observation, and final answer. Suddenly the model isn't guessing. It's copying a proven pattern, just like you saw with one-shot classification back then. Pause for a second. How do you plug few-shot into the ReAct loop? If you remember Part 2, you know the answer, but say it out loud before the screen reveals it. 3 mistakes that kill ReAct agents. First, forgetting to tell the model which tools exist. It's likely to hallucinate or get lost. Second, leaving out a loop limit. Your agent will run forever. Cap iterations to prevent infinite loops. Third, ignoring error handling. A single failed API call can cause your agent to get stuck or produce incorrect results. Fix those by listing every tool with its syntax, capping iterations, and adding a recovery rule right in the system prompt. Here's your blueprint. Start with a system prompt that tells the model it's an agent. Then give it a tool menu. Search, calculator, code execution. Show the exact action syntax. If the model still misbehaves, drop in a couple of few-shot traces. Set a loop limit to prevent runaway agents, and always log the full trace. That log becomes your audit trail when someone asks why the agent answered the way it did. Modern reasoning models often perform multiple reasoning steps before producing an answer. Some systems expose those steps, while others keep them hidden. As developers, we don't need to see every internal thought to benefit from the process. What matters is that the agent can gather information, evaluate evidence, call tools when necessary, and combine everything into a better final answer. ReAct made this style of reasoning popular, and many modern agent systems continue to use similar ideas, even if the implementation looks different. You don't have to build the entire ReAct loop yourself. Modern frameworks provide much of the infrastructure for you. LangChain, LangGraph, Semantic Kernel, OpenAI's agents, SDK, CrewAI, AutoGen, and Azure AI Foundry all help developers coordinate reasoning, tool execution, memory, and workflows. Although each framework has its own design, they all rely on the same fundamental principle. The model gathers information, performs actions, observes results, and continues working until the task is complete. Once you understand ReAct, these frameworks become much easier to learn. Companies aren't simply looking for people who can write clever prompts. They're looking for engineers who can build reliable AI applications that use tools, retrieve information, integrate with business systems, and handle failures safely. ReAct teaches one of the foundational patterns behind those applications. As organizations deploy more AI into production, understanding how agents reason, call tools, and make decisions becomes an increasingly valuable engineering skill. It's one of the building blocks that prepares you for modern AI engineering roles. Quick checkpoint. You just learned the 3 mistakes that kill ReAct agents. Here's one that trips up beginners. Let's see if you caught it. Last checkpoint. You need the square root of the number of countries in Africa. Which tools does your agent reach for? And what does that skill pay? Pause and answer before the reveal. You don't need a library to see the engine. 6 lines of Python give you the whole ReAct loop. While the agent hasn't given a final answer, you feed its response, parse the action, execute it, and append the result as an observation. That one line where you add the observation back into the prompt, that's the moment the agent stops guessing and starts knowing. The strength of ReAct isn't that it makes the language model smarter. Its strength is that it allows the model to gather information it doesn't already know. Instead of relying entirely on its training data, the agent can search documentation, query databases, execute code, or retrieve business information before answering. Each observation gives the model better evidence for the next decision. That's why tool-enabled agents are generally more reliable than models forced to answer everything from memory alone. Here's the biggest lesson from today's video. ReAct doesn't eliminate hallucinations, and it doesn't magically make every answer correct. What it does is give the model opportunities to verify information before responding. By combining reasoning with external tools, the agent spends less time guessing and more time working from real evidence. That's a major step toward building AI systems that people can trust. Once you start building AI applications, you'll see ReAct everywhere. Customer support agents search knowledge bases before answering questions. IT assistants query monitoring systems before diagnosing problems. Financial assistants retrieve live market data before making calculations. Enterprise co-pilots search internal documentation before generating recommendations. Different industries use different tools, but they all follow the same principle. Gather evidence first, then reason over that evidence before producing the final answer. That's why ReAct remains one of the most influential ideas in modern AI agent design. This week's plan. Step 1. Fire up Google Colab. Step 2. Paste the code from our earlier agent and install LangChain. Step 3. Run the agent with "What is the square root of the number of countries in Africa?" to see search and calculator work together. Step 4. Read the trace to really internalize the loop. Step 5. Swap in your own API tool, maybe a weather API, and publish the notebook on GitHub. That single project is a 6-figure resume bullet. Final checkpoint. Let's lock in the single most important concept from this entire video. Walk through one complete cycle of the loop, and don't skip the part that makes the whole thing actually work. Let's lock in what you've walked away with today. 1. You can now explain the ReAct loop from memory. Thought, action, observation, and why it grounds every answer in verified facts instead of model guesses. 2. You built a real agent that calls tools, wrote a system prompt, and ran a Python loop that solves multi-step problems. 3. You understand why this loop powers modern agent systems, whether it's LangChain or a closed-source assistant. Those 3 skills are your capstone. Hit subscribe and don't miss self-consistency prompting in the next one. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.